All right, Bass here. This is my second time. I still got Ari in the house. She heard me mess up. She said hi. She's doing fractions. And let's go over some of this homework. Some pieces that, I just want to make sure that you all are good on and trying to support you in the times of Corona. Yikes. All right. So this part about what a polynomial can and can't have, that's straight from the notes. I'm not going to go through that part again, but that is directly from the very beginning of the notes that I gave you. But let's use this information, and it's actually more than 4 things. I believe in my notes I gave you 6 things. So you should kind of have 1, 2, 3, 4, 5, and 6 different things that are things that a polynomial can't have. And now let's move over here and let's circle polynomial. So first of all, I know that this is a polynomial. This looks nice and pretty like a polynomial. I know that this is a polynomial right here. F of x is negative 10x. I know this looks nice and pretty as a polynomial right here. Now let's look at some of these more questionable things. One of the first things our notes is we said polynomials cannot have radical signs, no square roots, no cubed roots. That knocks this one out. Can't have square roots, cubed roots. Okay? It says polynomials cannot have division with x in the denominator. Ooh, that knocks this bad boy out right here. I can't have that. You know what? This is a clear polynomial. You can have decimals and regular exponents, so that's a clear polynomial. Let's see. I know that polynomials can't have x as an exponent. So that knocks this bad boy right here out of the game. Polynomials also can't have negative exponents. That knocks this bad boy right here out of the game. And finally, polynomials can't have fractional exponents. None of these are fractional exponents. You know what? That makes this a polynomial as well. So those are all your polynomials that are given in this list right here. What do you think about that, Ari? Pretty good so far?
Yeah.
All right, respect. All right, so you had to pick any of these functions and tell why it's not a polynomial. You should have been able to do that. That shouldn't be too hard. So let's go on to part B. What degree is this polynomial? Right here. It's the largest exponent, so it's a 3rd degree polynomial. Is the polynomial in standard form? Yes, because it has things being added or subtracted. If it was in factored form, it would have things being multiplied like so, but it doesn't. Ooh, what's the coefficient for the linear term? Remember, linear means it's a line, right? Y equals mx plus b. If that's linear, the linear term is because x is to the 1st power. So this linear term right here would be 6x, and the coefficient would be 6. And the leading coefficient is the coefficient with x to the greatest term. So my greatest term is x to the 3rd, so the leading coefficient would be -3. This part's just vocabulary, stuff that you guys got to do. I'm not going to go through number 2. You could have figured that out on your own as well. Let's go to this next page. Write each polynomial in standard form and classify them by degree. So standard form means I got to simplify some stuff. I got to put it in order. So this first one is weird, right? Because I have 4x. Oops. I have 4x and I have 1x. Well, why do I have those separated? So this would be 5x plus 2, because there's no reason for these two things to be separated right there. X to the 1st power is my biggest one, so there, I'm good to go. All right, this second one, I just need to flip these around. Standard form would tell me to put this in 12x squared plus 3. Now this one, to put it in standard form, I'm supposed to classify them by degree. This is a 1st degree, this is a 2nd degree. This one, this is in factored form. So I need to go ahead and factor it. And we just spent a whole unit doing this. So this part shouldn't be hard for you. This is x times x to the 3rd minus 1x squared plus 5. X to the 4th minus x to the third, because x to the first times x squared is x to the third. Negative 1 times 1 is negative 1. Negative 1 times 5 is 5, and x times nothing just leaves an x. So, if this was in standard form, this is x to the fourth minus 1x cubed plus 5x. Ari is really excited looking at what we're doing right here. You learning some stuff? She's like, nah, I'm not learning anything. All right? So that would be the standard form. I just multiply it through using my area model, and my degree would be 4. Standard form of this is just 5, and my degree is 0, because this would be 5 times x to the 0 power. Because remember, x to the 0 power equals 1. So it's really like 5 times 1. All right, boom, boom, boom. So let's check out what we have here. Standard form, factored form. The roots are where the outputs are 0. And here's the key. Roots are the same as your x-intercepts. Okay? Roots and x-intercepts mean the same thing. So I'm looking. Here's the standard form. You guys just did a whole unit on how to factor it. If I was to factor this, I would get this. I shouldn't have to do that for you. And then if I wanted to find the x-intercepts are where y equals 0, right? So if I plug a negative 2 in here, right, I end up with negative 2. Let me make this bigger. Negative 2, negative 2. I should get an output of 0. Let's see if that's true. Well, negative 2 times 2, or excuse me, plus 2 is 0. I end up with 0 times negative 6, and 0 times negative 6 is 0. Meaning that negative 2 is one of my x-intercepts. You should probably know that the other one of your x-intercepts would be negative 3. The reason why that is, if I plug a negative 2 right in here, this becomes 0, and 0 times anything is 0. If I plug a negative 3 in here, this becomes 0, and 0 times anything else here will be 0, okay? So hopefully you have that piece of it. So it's asking me to find the roots. I'm going to do this one. This one should be easy. I'm not even going to talk about this one. Let's find the roots. Well, what do I need to make this factor right here become the number 0? Well, ultimately, I need 3x plus 2 to equal 0, right? Because I need this to be 0 times x minus 3, whatever. It doesn't matter what number I put in here. So this is some easy algebra to solve. Minus 2, 3x equals negative 2. Divide by 3, divide by 3. X equals negative 2/3. Okay, so that means that one of my roots, let me go ahead and erase here. That means that one of my roots, a root, is x equals, what was that, negative 2/3. My other root, which is easier to find, well, how do I turn this into a 0, is x equals 3. So my x-intercepts are at negative 2/3 and 3. Okay? I'm not going to do this third one because I just showed you how to do it. But this one, notice that this has 1, 2, 3 x-intercepts. This has 1, 2 x-intercepts. It matches with the number of factors. This has 1, 2, 3 different x-intercepts. All right? So now I got to take that information and put it into here. Shout out to Dana. Hit me with an email. Ask me about number 4, part E. I appreciate you for getting at me and let me know. I don't know how to do this. So, well, let's write a polynomial in standard form. Well, what do I know about this thing? I know it has 3, 1, 2, 3 x-intercepts. And I know exactly where they are. So I can write this in factored form. I can say y equals, well, my first intercept is at negative 1, negative 2, negative 3. So something plus 3. Remember, because it's always the opposite, right? Because if I wanted to find the x-intercept to make this become a 0, I would need x to be negative 3, meaning That's where it is. So y equals x plus 3. This x-intercept is 0, so it could be x plus 0, which really you wouldn't write as x plus 0, but you could. You just write it as x. So I got 1 intercept, 2 intercepts. I just need my third intercept. This is 1, 2. So this is x minus 2, right? Because if I plug 2 in here, I end up with this 0. So this is my factored form. How you doing, Ari?
Good.
Good?
Yeah.
I'm almost done. And then we'll look at what you're doing. Right? But they didn't ask for factored form. They asked for standard form. So what do I do to this factored form? I take it and multiply it through. So I'm going to do x times x plus 3. And I end up with x squared plus, x squared and 3x. So now I have x squared plus 3x times x minus 2, my last factor. And I can do that. Boom, boom, boom. X squared, 3x. Here's x minus 2. X cubed, negative 2x squared. 3x squared, and negative 6x. Right? I'm just going to erase some stuff so I can then get there. Which means I finally, in my standard form, I have y equals x cubed. Negative 2x and 3x is plus 1 x squared. Use that. Use those. Minus 6x. That is standard form. So I had to kind of put all that stuff together that I just did. So now I will do one of these. I'll do number 5. Write a polynomial in standard form with given the roots. In other words, if I know the x-intercept of this is negative 4, I know the factor is going to say y equals x plus 4. If I know this x-intercept is negative 2, I know the factor is going to say y equals x plus 2. Because when I plug negative 4 into here, I get a 0. And 0 times 0 is going to give me an output of 0. If I was to plug negative 2 into here, I get a 0. And that will ultimately get me that output of 0. So here would be a polynomial in factored form. Ooh, but you got to put it into standard form. So remember, this is factored. I'm going to let you figure out how to put that into standard form. And you can finish off this last one over here. All right, y'all. We're figuring this out as we go. We're making it happen. You guys are doing great. Check this. We might do some Zoom meetings so we can all get online and get extra help. I'm kind of figuring this out as we go. So please stay on Google Classroom. Please continue to read. Please continue to turn in stuff, you know, every day or two, because I'm going to keep giving you guys work. All right? Hold it down. See you later.